All right, so this is a talk about Empire, or PowerShell Empire, depending on how you want to call it. And it's merely an introduction. So this is a tool that I really have nothing to do with, except I've been writing a class around PowerShell attacks and how to defend against them. And I've been using PowerShell for the offensive portion of that. There are probably people in this room that know more about Empire than I do. If you've ever used this tool, raise a hand. So why are you not up here giving this talk? That's what I want to know. So Empire was written, it debuted at B-Sides, Security B-Sides, Vegas 2 years ago. So this is a relatively old tool at this point in terms of internet years. What is it, like 100 now? So PowerShell Empire was written by these three fine folks. I need to give them full credit. I had really nothing to do with it. I've only been a user and only for a very short while. So another way of saying that is, let me manage expectations here. I know almost nothing about what it is I'm presenting about. So there you go. So Empire, according to its creators, is a pure PowerShell post-exploitation agent built on cryptographically secure communications without needing powershell.exe. So if you haven't seen some excellent talks online, go YouTube PowerShell without PowerShell, and you'll see that really all you need is the system management automation, DLL. You can inject that into pretty much any process, and now you can use any process to run PowerShell commandlets, which is kind of a beautiful thing. PowerShell Empire also is, according to the authors, it contains rapidly deployable post-exploitation modules. There's 260 plus of them to date, ranging from keyloggers to Mimikatz. It features adaptable communications to avoid network detection, all wrapped up in a usability-focused framework. And that's it for boring slides. If you want to know more about PowerShell Empire, well, I'll come back to boring slides in a bit, I guess. Go to this website. I set this thing up on an RHEL-based box, so Red Hat CentOS box. That's what I'm going to be using for demo. Most of the talk is going to be demo. Setup assumes you're running on some Debian, Ubuntu-based system that has apt-get. You can still figure out how to get the thing installed if you just open up the setup script. If you're running RHEL, you can make it work, but it will take some more manual labor on your part. So with that, let's jump into a demo. So pray to the demo gods that everything works here. All right, so I'm going to be operating from this host here called Client 4, and apologies if you're in the back and you can't read it, come up front and you'll be able to see it better. So Client 4 is the machine that I've got Empire installed on, and basically you can download this thing from the previously mentioned website. It's on GitHub. It's probably where you'll find the latest bits. You'll find a link on the previous mentioned website, but you fire it up, you're running Empire. And of course, they give you a cool splash screen, which is a stormtrooper mask there. So you've got to have the cool factor. And basically, you're sitting at a prompt. So those of you that have used Metasploit or you're familiar with Metasploit, it's kind of similar in terms of the way things work. So let me see if I can hold the mic here and type and talk at the same time. There is a quick start guide on how to use this thing, and a couple of my teammates have been using this too for the classes we're working on, and everyone has come to the same conclusion that the documentation kind of sucks. So if you're using the quick start guide, the one thing they don't tell you in the quick start guide is the first thing you need to do is create a listener. So Empire is basically command and control. So you're going to be running this back-end piece on some Linux system, right? It's all Python based. So maybe you can get it to work on Windows. I don't know, I haven't tried. But the first thing you want to do is set up a listener. So with that, you can go into a context menu for listeners, and the way you do that is type the word listeners here. Tab completion is your friend when it comes to this tool. So you can go into listeners. I've got a listener already set up. My listener in this case is called HTTP1. It is an HTTP-based listener. In this case, I'm actually using a self-signed cert. So everything is communicating over TLS. So that speaks to the secure communications protocol. If you don't have a listener already set up, which I do in this case, from here you could type use listeners, and again tab completion is your friend, so after you type use listener, hit space, hit tab a couple of times, they'll show you all the different types of listeners that you can use. So to configure a listener, if you want to configure the HTTP listener, you type use listener HTTP, and then you're taken to a new context menu. Typing the word info here will show you the settings for that specific listener. And if I reduce the size here a bit, maybe we can get it all to fit on one screen. So there's a bunch of different options in here. I won't go through them all. The main thing you want is make sure you've got a name for your listener. All the other things that are set here are basically default settings, except that I created a self-signed cert so I could do everything over port 443, but you could do it over port 80 if you wanted. Once you've set all your options in here, and that's just simply typing set, and whatever the option is, and then some value. So in this case, I could say, hey, let's change the name to HTTP1, which obviously it already is, but this is how you set the options. Just set, name of the option, and some value. Once you've done all that, and you've got everything configured the way you want it for the listener, typing the word execute here will fire up the listener. In this case, I've already got a listener running, which is why it's complaining about port 443 already being used, because I already have a listener running. So we can jump back a couple of context menus here, and you can see there's 266 modules. I have a listener that's currently active. I have 0 agents currently active. So if we jump over to a Windows box, so I've got a Windows machine here that we want to compromise, and we'll just go through a basic compromise scenario. Let's say it's a phishing scenario and I've stolen credentials. Oh, that's not the right host. Hold on a second. I have VM inception going on here. I've got to scroll down, I think. So on this machine, maybe. Let's fire a PowerShell prompt on this box. Oh. Hot corners. Gotta love it. All right, so on this machine, I'm logged in as norm no admin. This is a user with no admin privileges, which we can prove here by doing whoami/all. And you can see, based on my SID, I'm not an admin user. You can see I'm not in any admin groups here. So a really common PowerShell attack that's one of the top 3 go-to tools for red teamers that I've talked to and interviewed that use PowerShell is something called get GPP password. Anybody familiar with that attack? Anybody used it? Raise a hand if you've heard of it. All right, so this is a fun one. So Microsoft has this thing called group policy preferences, and you can use group policy preferences to manage local admin passwords. So if you want to set local admin passwords across your entire enterprise, you go into group policy preferences and you say, hey, I want the local admin password to be this. And it'll write it out to a configuration file that sits, it's an XML file, sits on sysvol. So any authenticated user, any authenticated machine can read this file off of sysvol. It contains the local admin password. It's AES encrypted, so don't worry.
Nobody's ever going to know the key.
Oh yes, Microsoft published the private key. Good job, Microsoft. Former employer notwithstanding. So yeah, Microsoft published the private key for this. They can't roll it because, I don't know, there's some big customers that probably need it. They don't recommend using group policy preferences. If you're on a fully patched Windows server domain controller, you can't use group policy preferences for setting passwords anymore. But if you ever used it in the past, the password's still going to be sitting out in your configuration file. Another thing that I know red teamers like to do is just set the password in the configuration file. So they'll just, once they've compromised the environment, they want to change the local admin password everywhere to make it easier for them. They'll edit the file and just put the password in it. And then in 15 minutes, when every machine updates, they'll all have the same local admin password. So that's a good time. So I'm logged in here as a non-admin user. Let's see how easy it is to become an admin. I'm going to jump back over here and reduce the screen size so I can see what the hell's going on. I'm going to steal a bit of command line foo here. So this is something that recently people have been talking about on Twitter, red teamers that I follow. They're using the certutil command to download files from the internet because they think it's sneaky. I encourage all red teamers to use this. By the way, I'm a blue teamer, if you didn't know. Let me see if I can copy that to my clipboard since it didn't copy. Or we'll have demo fail, whichever.
Type it out.
Oh, geez. I really don't want to type it out. And I don't think I have it in my command line history, but let's do this anyway. So we'll run certutil. -split -f. I have no idea what these commands do. I just see things on Twitter and I type them in. HTTPS. And this is a Google shortcut to what looks like a legit PowerShell repo. FUWXD7. FUWXD7. I think that's right. So this is just going to download a file, maybe. Let's try this again. Oh, I left out a keyword there, URL cache. Gotta love live demo. All right, so that downloaded this file. What's in this file? Well, if you're curious, this is the get GPP password attack. So you can look at this file. It's a PowerShell script. It contains all the code in it, including the AES private key needed to decrypt the password from sysvol. So how do I run this thing? Well, if I'm in an environment where we've got PowerShell execution policy set to restricted and you can't execute arbitrary PowerShell, Microsoft will tell you that's not a security boundary. The easy way around this is to get the content of that file and pass it out as a string, and then pass it to invoke expression, which is actually going to instantiate that script in memory. And then I can call the command get GPP password. And if we run this, it's going to dump the local admin password to the screen there. I'm going to be really lazy, and I'm going to pass this out. Let's just select the password. So we'll do a select, and I just want the password property, so I'm just going to select the password's property. And I'm going to pass this thing off to the clipboard so I don't have to fat finger it. So now I've got the local admin password in the clipboard on this machine. So let's become local admin. And we'll run a PowerShell prompt here. Assuming I didn't fat finger anything. So we're doing a run as user client1 local administrator, and we're going to run a PowerShell prompt. And it's prompting me for the password, which is in my clipboard. So let's just dump that. And now you can see I've got a new prompt here, or a new window at the top of the screen. This is my, if we run who am I here, /all, you'll see, let's do this differently. So now you can see I am a local admin, and I'm in the admin group. I've got all kinds of privileges assigned to me. So there's my user SID now, ends in 500. So now I can do things with privileges on this box. So one thing I might want to do is run a PowerShell agent and run it in a privileged process. I can run PowerShell agent in a non-privileged process. You can run the PowerShell Empire agent in a non-privileged process and do this get GPP password attack from the non-privileged process and get the password and then pivot into some other process you want and gain your privileges if you'd like. But I just like doing it this way because everybody can get phished, and once the credentials are stolen, if I can get access to your box, I can go from your non-admin account to an admin account using this attack in what I'm told, according to red teamers, is most customer environments. Maybe not true in your environment, but true in this one. All right, so let's set up an agent. So we jump back to Empire, and what we have to do here is create a stager. So from here, if you type use stager and hit tab, you'll be presented with a list of different stagers that you can build. And the one I've been using is obviously for Windows environments, and I'm kind of a fan of the launcher VBS stager. So that'll take me into that context menu, and if I type info here, it gives me, hey, here are all the options. So as I said, you can set the options here. I'm going to set my proxy to none. This thing is proxy aware. It can proxy through if you're running web proxies. You can tell it to use your web proxies. I don't need proxy creds, so I'm going to set that to none. And I'm going to set my listener to, this is the most critical piece, set your listener to the listener you created earlier. In my case, it's called HTTP1. You can change the user agent if you'd like. For my case, I'm just going to set the user agent to be none. And once I've got all my options set, I can type info again, make sure everything's set the way I want it to be. And then from here, I can type execute. And as it says, it writes out a file, temp launcher VBS. So in another window here, if it's still open, we can cap the contents of this launcher. And what we have here is a VBS script. So a VB script that will invoke a PowerShell command and run this base64 encoded string, so this big long command here. And we can simply copy this to a clipboard. And from over here, if we fire up Notepad, and of course I'm doing this in a way that's leaving all kinds of evidence on disk, so you may want to do this differently. I've already staged this file, so I'm just calling it l.vbs. So this file already exists on the machine. If it didn't, I could just drop it in. This thing is here, so now we can do cscript. A little anxious on my tab completion there. l.vbs. And that opens up a new PowerShell prompt, and if we hop back to the PowerShell Empire screen, you can see now at the bottom of the screen I've got an agent reporting. So I have my first agent. So if we go into the agents menu, any agents that you have calling home are going to show up here. You can interact with these agents. So tab completion again is your friend. So from here, there's a bunch of different commands you can do. You can type help pretty much anywhere in PowerShell Empire. It's going to give you context-sensitive help menus. So I could do a sysinfo command here, and it's going to, the default settings for PowerShell Empire are pretty chatty. Every 5 seconds, this thing is calling back to C2. I recommend, as a blue teamer, go ahead and leave it at the default setting. Or make it every second. I mean, why wait? Unfortunately, I mean, this is an open source thing, so you could edit, you could change the periodization for the callbacks to be some random value, but don't do that. That makes it too hard to find you. So yeah, there's some details about the agent, and if we jump back and we list the agents, note the context for the process here. It's running as administrator in a PowerShell process. That PowerShell process could die and this agent would die. So one of the things you're going to want to do as an attacker is pivot this agent into some other long-running process. So to do that, super simple, go into the agent in interact mode and do ps inject, and you want to know what listener you want this agent to call home to. In this case, let's call back to HTTP1, and let's pivot into LSAS, everybody's favorite. So within 5 seconds, this thing is the agent's going to pick up the job, and it's going to pivot this agent into the LSAS process, and we'll see a new agent report. And there it is. So now I've got 2 agents running on this box. One is running in the PowerShell process. One is running in the LSAS process. So if we jump back here and we list our agents, we can go ahead and kill this one. That's the PowerShell process. We don't need that anymore. We're now running as LSAS on this machine. So let's interact with that LSAS process a bit. So from here, I could do things like, I could run Mimikatz. Maybe. Shouldn't take that long. So things, oh, well, there we go. I guess I can't count to 5. Everything's faster when you're standing up here behind the mic. So the Mimikatz job is started, and pretty soon we'll see the output of the Mimikatz command dumped to my screen here. And there we go, there's the output of Mimikatz. You can run arbitrary shell commands, so we could do, hey, let's see, what are the network connections like on this box? So there's your netstat output. Do note, so next I'm doing queue user, let's just see who's logged into the box. Do note, as a red teamer, I love it when you do stuff like this. If you're running an LSAS and you're spawning processes from LSAS, that's my favorite. There's a bunch of built-in commands that, like Mimikatz, have no visibility into without doing something like memory analysis of the LSAS process. But anytime you run an arbitrary shell command, that's something that's relatively easy for me to find. So that's kind of PowerShell Empire in a nutshell. So Awesome, if he's here, or she, I don't honestly know, sorry, was hitting me up on Slack and saying, you know, I'm glad you're presenting on PowerShell Empire or Empire, we need more offensive talks. And this is apparently a tool that he has used before, so hopefully you're going to do other presentations on this in more depth. But I would be remiss, there's a lot more stuff this can do, obviously. So if you want to get a flavor for the kinds of things you can do with it, just type use module, and there's over 266 modules, I think it is now. This thing can do all kinds of crazy stuff. You can dump certs, you can dump the current TGT, so you can have your golden ticket attack, you can, every red teamer's favorite here at the bottom, you can troll people with it on the blue team. But I would be remiss if I didn't, as a blue teamer, talk about defenses. So let me jump back to the slides real quick, and we'll talk about some defenses and detection for this thing. So detections and defenses, how do you figure out that this thing's running in your environment, and what do you do to keep it from running? First of all, if you're running PowerShell v2 in your environment, you deserve to get hacked. So upgrade to the latest Windows Management Framework 5.1, I think is the latest. It comes with script block logging, so every PowerShell script that gets run gets logged to the Windows event log, and you can mine those things for interesting things. So you'll be able to see the user agent when it spins up in your environment. You'll see that in the script block log. Furthermore, uninstall PowerShell v2. If you install PowerShell 5.1 via the Windows Management Framework, it will not uninstall PowerShell v2, and you can bypass all of script block logging just by doing PowerShell-v2. Then you'll be running PowerShell in version 2 mode without all the cool logging that they've implemented. If you want to go further, implement constrained language mode. I've worked in environments where this has been done. I've never set it up myself. It's, I think, somewhat complex to set up and get running, but worth doing. Monitor for odd parent-child processes. So for those of you in the back that can't see this, let me see if I can make it bigger. That's not right. So you can find things like LSAS spawning netstat or LSAS spawning queue user if you're silly enough to do that kind of thing. Obviously, you've got to know to go look for those things, but there are ways to monitor all the parent-child relationships in your environment and have those things bubble out. If you like it presented graphically, you can have it presented graphically, maybe a little easier in your environment. Monitor for odd network activity. As I said, PowerShell Empire is fairly chatty, so in this case, I've pulled out all of the network activity for LSAS in this environment over several days, And the only thing that's communicating out from LSAS over port 443 is communicating to a different IP address than everything else, and it's only on the machine I compromised. So there are ways of finding this. I mentioned the system management automation DLL, that's the PowerShell DLL. That thing is going to be loaded into the LSAS process when you pivot into the LSAS process. So if you run list DLLs across your entire environment, you'll see this thing. That particular DLL will be loaded into LSAS, which is what's showing on the screen here. You'll also see this DLL loaded into some legitimate processes. So if you see it in System Manager, I think is what it is, or if you see it loaded into powershell.exe, that's all normal stuff. But if you see it loaded elsewhere, you might want to dig a little deeper. Recall can find this. So Recall has some anomaly plugins that you can run, and they will find the thread loaded with anonymous kernel address. Other things that you can do, the standard defensive stuff, so egress filtering, least privilege, you saw how well that worked. Expense in depth, defense in depth supposedly works, and security is hard. So that's it for PowerShell Empire. Go check this thing out.